One of the things that we can do to make sure that we have understood a problem is to rephrase it in our own words or restate it in another way so that we can make sure that we understand it. And for this task, my way of rephrasing it is to say that we are going to create a simulation of an ant moving around. We're going to place some food and we're going to see if the ant can reach this food. There is a restriction that the ant can only take one step at a time and that the step will be randomly selected. It will either move left, right, up or down. And one other thing is that there is a limit for how many steps this simulation can take. There is a limit of 2,500. So if we find the food within this number of steps, we have succeeded. And in the end we will show a message saying if we succeeded or if the ant didn't find the food in that number of steps. And taking a look at the description, we can see that we get a lot of information here for how the script shall work. So I'll mark a few things here. For example, we see here that the ant starting position is a tuple. We're also given that it should be 0, 0, but I'll just mark that it shall be a tuple so we remember that. It's the same for the food, that's another tuple. If we continue looking, we see that there shall be a function called move. Alright, we know now that we have two functions, we have main and we have move. It tells us that it takes an x and a y as arguments or as parameters. We are sending an x and a y when we're calling it as arguments, but in the function they are parameters. So x and y, not as a tuple. I'll mark that so we remember that this is important, that it takes two values, not a tuple. And then what should it do? It shall increase or decrease either x or y by 1. So we know that this function called move, it has two parameters, x and y, and in the function it will increase or decrease x or y by 1. And it's returned as a tuple. I'll mark new tuple so I remember that that is what I need to do. I need to create a new tuple. And then for how the script shall work in general, we shall call the move function over and over again in a loop to move the ant around. And here we see the limit that, alright, we shall stop if it hasn't found the food after 2,500 steps. So what shall I mark here? I think I will mark move function over and over again. Finds the food. That is one of the conditions, or the other condition is this 2,500 steps. So somehow we'll have to keep track of how many steps we take. And finally display a message telling if we find the food or not. Right, so here we have marked a few things that when I read it, I saw that this is something that is important for me to understand what I need to do. And we started out with rephrasing it. So now I'm pretty sure that I understand it. Now let's try to devise a plan, which is step number 2 in Polya's problem-solving technique. And as usual, I will try to draw a flowchart for it. We can start with the main function here. And as you can see, I started by adding the main function here, and I also added 2 more things. This is the initialization as I see it. First, we initialize the ant and the food position. We were told here that the ant starts at 0, 0 and the food has another position here that we can see in the range -10 to 10 for both x and y. So that is what we do first. And after that, we were also told that there is a limit for how many steps we take. So I set the number of moves to 0 to begin with. When we have this, we can create a loop that moves the ant around as long as we haven't reached the number of steps or found the food. And we can see here what I did is that I said that, all right, as long as we have moves left and we don't have a match yet, what we do then is that we move the ant and we increase the number of moves we have made. Then we go back and we check again if we have moves left and we haven't reached the food. Then we do this over and over again until we either reach the limit of number of moves, or if we find a food, then we are finished. But there is one thing I forgot here. We should also display the result. So let me add one more thing here, that we should display the result. All right. There is, however, one thing left to do, and that is to create the move function. We don't have that, so we'll add that one here. And I also added that we should increase x or y, because we see here when we had the text here that we should, in other words, we should increase or decrease either x or y by 1. So that is one thing that we shall do here in the move function. So that is added here. And when we have increased that, we can make sure that we create a new tuple. So what I mean by this one, calculate new position, is to actually create a new tuple that we will then return. So we have the main function and we have the move function. And if we take a look here, I'll just change the arrow here. So don't have an arrowhead. There we go. So when we start the script, we initialize the ants and the food position. After that, we set the number of moves that we have made to 0, because we need to keep track of how many moves we have taken so far. Then we keep moving the ant around and increasing the number of steps until either we reach the limit of how many moves we can take or we find the food. So we keep going in this loop, and then after that, when we have either reached the limit or we have found the food, we display the result and we're finished. And how do we actually move the ant around? We can see that in the move function here. My plan is to increase either x or y, and the increase will be from -1 to 1. So we can decrease or increase either x or y. And after that, we create a new tuple, or to calculate a new position using what we found out here. That is what is returned back, a new tuple. And the implementation of this we will see in the implementation video.